Okay.
Hello, everyone. Sorry we had some
technical difficulty.
It wasn't my fault this time. Promise it was not me.
We were a few minutes late. Sorry about that. So this is our 5th episode. We have talked about what robot we have, how to sense the environment, how do you know about different sensors which can be connected to the cloud, how do you send the data to the cloud, and once you have it in cloud, how do you process it? And once you have the processed data, the data can be sent to the robots, and robots act on it. So today's episode is focused on how do robots act on it. So once you send commands to a robot, how can robot do different actions with that data? So today we're gonna focus a lot on that piece, and we have a special guest with us as well.
Yeah, we do. We have a special guest, Brandon from Robotis. So he'll be joining us here in a minute. So Anupam, you want to, for the new folks, do you want to introduce yourself? And
Sure, yeah. My name is Anupam Mishra. I'm a solutions architect here at AWS. I focus on a lot of things which happen in Bay Area and how our customers use those services. Very excited to be involved in this project. This is something we have been working on last many months, and hope to take it to a much higher level in coming months.
Yeah. Hi, and my name's Todd Varland. I'm also with the Solution Architecture Organization here in San Francisco. And we're broadcasting live from the AWS Makerspace at our office in downtown San Francisco. And Trevor?
My name is Trevor, and I don't know what happened earlier, so I'm really
It's all
sorry.
your fault.
Yeah, I think we're good. I think the turtle was a little angry before since you didn't want to show.
Okay, it's turtles all the way down.
And this is the turtle he's talking about.
Yeah.
Todd doesn't like the turtle. Todd thinks the turtle doesn't belong on the table. But it was 2 against 3.
Okay.
Awesome. Cool. So let's move into today's episode. We want to talk about what this robot can do and how does it do it. So before...
we have to have lab codes.
Oh yeah, let's do the demo. And
Is demo time?
Yeah, demo. It's demo time. So
We need music. We need music for demo time.
We started
Yeah.
a tradition.
All right.
We have to do a demo with the lab codes on.
Yeah,
putting our lab
so
codes.
Trevor got us awesome lab coats. So we bring out the lab coats for the demo time. All right.
Awesome. So
all
let's start.
Which demo are we doing?
We're doing the robot arm.
Yeah. So we are still on the same one. Let's see. So as you can see, I don't have any device on my hand, but I have a leap motion right here. It's a little bit hidden because of the echo right there. Let's let it. I'll keep it on the table. But you can see as I move my hand, this robot mimics my hand motions. I can do left, right. I can close my palm. It can pick objects. We have done those experiments a lot of times. You can put one of those soft toys, and it can pick those objects. And I think the possibilities are a lot. Like you can think about adding wheels to this device, adding some artificial intelligence to this device. We are going to go into all those areas, but today we are focusing on how is this robot doing all this? Like once we have the commands on the Raspberry Pi, how does the robot take those commands and make those movements? So
for context for folks, so you've got the leap motion connected to your laptop, and we're publishing the data into AWS IoT from here in San Francisco into Virginia, and then we have a Raspberry Pi subscribing back the data back here in San Francisco. So literally, your hand motions are going round trip between West Coast to East Coast and back again in the time in basically about 80 milliseconds?
Yeah, I think it's a pretty good example of how you can control different devices. Like you send the data to the cloud, and cloud can send the data across multiple places. So one of them is Raspberry Pi in this case, but you can imagine a lot of robots taking different data points from the cloud and acting on it.
Great.
So if I don't have a Raspberry Pi, can I use the Arduino?
Oh yeah, so you can use any single board computer you want. It could be Raspberry Pi, it could be a laptop, it could be Arduino, it could be something else. There are a lot of boards available. As long as you can run Python code on it, it works. For this example, we are using Python, but you can write other C language as well. Like we have SDK for C.
Node, C, bunch of different languages.
Yep, and for those who have not attended or seen some of our previous episodes, I just quickly wanted to tell you how to understand that. We already have the videos on YouTube. If you search for AWS Maker Studio, you will find those videos. The first episode was focused on what components go into this robot. The second episode was focused on sensors. How do you sense the data? third episode was focused on how do you, once you have sensed the data, how do you send that data to the cloud? And the fourth episode was focused on how do you make sure different things can be done in the cloud? How do you make your brain of the computer or brain of the robot? You can do a lot of things in the cloud, so showing different value propositions of doing it. And this episode completes the end picture, which is once the data is in the cloud, how do you take that data onto a device and actually make something cool with that data?
So today we are going to have Brandon from Robotis. We're going to go deep into the hardware this time, and then we're going to wrap up with Anupam showing the AWS IoT subscriber code on the Raspberry Pi, like Anupam said, to complete the picture. So are we done with the demo and ready for Brandon?
Sure, yeah.
Yeah.
I mean, for a much cooler demo of this arm, definitely check out one of our previous episodes. But in the interest of time, we are just showing what this does. But it can do a lot of other things.
Great.
Let's welcome.
Bring in Brandon.
Yeah, let's bring in Brandon, and let's lose the lab coat since the demo's over. Brandon, welcome.
Hey, how's it going, guys?
Great. Thanks for joining. And so where are you today? You look remote. So where are you broadcasting from?
So I'm broadcasting from Robotis Inc. in Lake Forest, California.
Awesome. Cool. So why don't we start off? Why don't you just tell us a little bit about, who you are, what your background is, what your role is at Robotis?
Sure, yeah. My role today at Robotis is I'm the technical specialist and STEAM consultant. So Robotis actually has two lines, which we can get into a little bit later. We have what we call our K category, which is our K through 12 education platform. And then we've also got our D category. Everybody knows us. Well, some people know us, but everybody knows Dynamixels. Not a lot of people know that Dynamixels are made by Robotis. And so my background over the last 7 years or so, I started out as an automotive technician and did a little bit of school, and then saw some cool projects that I wanted to be a part of, and eventually made my way into the robotics community.
Awesome. Great. So how did you get initially interested in robotics? And we all know there's a little backstory here, but why don't you share it with the audience?
Oh, man. Same story I've been telling for the last 7 years. We're going to have a hard time keeping it down to 40 minutes today. I used to be an automotive technician, and I had the aspiration of becoming an automotive engineer. And so when I joined Mount San Antonio College back in late 2010, early 2011, I was handpicked for the robotics team. They were going to a competition called Robo Games in 2012. And the reason I got picked was actually because I had no experience with true robots in the sense of like closed loop autonomous or anything like that. I was picked for the team because I was really good at turning wrenches, which was based on my background as an automotive technician. And they had an autonomous vehicle platform called RoboMagellan that they asked me to be their fabricator and mechanic for.
That's cool. Is turning wrenches, is that an inside joke for automotive technicians?
I mean, it's maybe yes and no. It's not always turning wrenches. Sometimes it's, sometimes you got to fix the loose nut behind the wheel. A lot of it is the customer. That's an automotive joke. But it was really just the mechanical aptitude. That's what they were looking for somebody to be their platform specialist for the RoboMagellan hardware aspect.
So what got you inspired on robotics specifically?
Okay, so I love to tell this story. So when I was at 2012 Robo Games, I can tell you the exact moment that I knew I wanted to do cool things with robots. And so at Robo Games, so Robo Games used to be called the Robo Olympics. There's lots of different categories, but the main event is always the combat robots. And so I was there for RoboMagellan, and after the RoboMagellan match had finished, I was sitting in the stands, and there was this robot that everybody kept talking about. It was a brand new robot called the Electric Boogaloo.
You want to show that?
And there's this other robot.
Go ahead and finish.
Sorry.
We'll show it after this.
Yeah, right.
So Robo Magellan.
So Electric Boogaloo was a very powerful vertical spinner, and what was he was making a lot of waves because it was a brand new robot and nobody expected it to do as well as it had been doing. And one of the main contenders for the 220-pound heavyweight league is Last Rites. So you have Last Rites, which is the hands down the heaviest horizontal bar spinner. It's got a 75-pound spinning bar that has a tip speed of over 200 miles an hour. And then you have Electric Boogaloo, who had been, just taking names left and right. And finally, they ended up in the semifinals. They ended up facing each other. And so it was like, oh my gosh, what is going to happen? You have the this is like Godzilla versus Mothra.
Oh, wow.
And so the match starts, and both robots spin up. They're kind of, figuring out what the other one's going to do, kind of sorting their strategy. There was no box rust, which was kind of
all right. So let's do a voiceover.
And then both weapons.
Let's see the video, and so you can talk through kind of what's going through your mind.
So the one on the left is Robo Magellan. What was the name of it?
Last Rites versus Electric Boogaloo.
Yeah.
Oh.
Sorry, Last Rites would be in the blue square, and Electric Boogaloo is in the red square.
Oh man.
One is vertical, one is
So
horizontal.
both robots go together. Last Rites rips off the front armor of Electric Boogaloo. Electric Boogaloo manages to flip Last Rites around.
That's crazy.
You sent us another
I mean,
video.
these are 220-pound robots. So like every time they come together, it's like a small car accident. It's no small feat to have 220-pound robots flying 30 feet across the arena. Just to give you a sense of scale of the forces that are involved here.
Wow. That's awesome.
What are these blades made of?
So everything. A lot of aerospace engineering materials, like titanium, and but usually the weapon tips are made out of a alloy called S7 tool steel. That particular bar that Last Rites is running for his high moment is a 2024 aircraft aluminum bar, and then it has steel tips. So the moment arm on that when it spins up is just tremendous, because the further you can get your dense mass away from the center of rotation for the same angular velocity, you just get a ginormous increase in the amount of stored energy.
Okay, so at this point, what's going through your head, and what are your thoughts about robotics?
So the moment that the robots came together for the third time and Last Rites slapped to the glass, my pants turned a different shade of brown. And that was when I realized this is what I want to do for the rest of my life. Because I mean, if I don't do anything else, I have to build a combat robot.
Okay,
that's cool.
Awesome.
And so,
did you see any robots?
So that was what inspired me to. What? Oh, go ahead.
Did you see any robots that were? I mean, I used to. What was it called? The show BattleBots or Robot Wars?
Robo Wars.
Robo
Yeah.
Wars. Did you see any robot?
Absolutely.
That had a chance to do a almost like an elevator. Elevator just launches the opponent robot in the air, which is complete as like a backflip or front flip. I mean, I guess what would it take? I mean, I imagine to do that kind of force.
Really powerful pneumatics. So if you've watched the most recent season of BattleBots, there's a robot named Bronco. And so Bronco has one of the most powerful pneumatic flippers in the league. Maybe even the most powerful currently running.
That's cool.
Wow.
Awesome.
Don't quote me on that.
So these are like
yeah,
Servos,
he
right?
can flip a 200-pound object 90 in the air.
Perfect. So now that we're sufficiently inspired, let's dig into what are the pieces and parts, right?
Yeah. When somebody wants to learn about servos, right? There's so many types. Can you talk about like what types you have seen and where are they used? How are they made?
Sure, yeah. So when it comes to servos, there are what we call like our general hobby grade servos. So I've actually got one in front of me here. And I'll get a little bit into what categorizes something as a hobby servo versus the intelligent or smart servo actuators. So you can see that this hobby servo has 3 wires. for the standard servo protocol. You got power, ground, and signal. And then another telltale feature of the hobby servos is that they've actually got limited rotation. So it's maxed out on one side and maxed out on the other. So they do make continuous rotation servos. Would you, have I said enough about that hobby servo?
Yeah, so yeah, I think that's good enough. And then the hobby servos run about how much each? Quantity one?
Hobby servos are anywhere from a couple dollars to, they do have like high performance versions that are in the hundreds of dollars.
Okay, cool. So what are some of the other kind of servos and motors?
So other servos, we have intelligent servos, which have an onboard controller that can sense things like load, usually by measuring current. They can also sense the voltage or temperature. And so what usually distinguishes a intelligent servo versus the standard grade hobby servo is the ability to sense the speed that the rate of speed that it's moving at, and give you feedback for your closed loop system that give you insight about what's going on with the environmental variables. Like I mentioned, temperature, voltage, load as measured by current. And these are all important things, especially in the case of like when we get into robotics and there's human-robot interaction, you definitely want to be able to measure load in the case that there's like a human in the way of the actuator that's trying to move through the human, and you don't want to harm the human. Or in the industrial applications, you don't want the actuator to accidentally break parts because something is in the way or jammed or anything like that.
Nice. Yep. So where have you seen these used? Like, are there specific use cases where these are used?
Oh, all over. Everything from animatronics to hobbies. You can use the 360-degree rotational servos as a metered motor device. So you can actually give intelligent capabilities to the motion system of your robot, and track how far it's going and give correction for one wheel moving faster than the other, or if a robot is under significant load, it can figure that out by seeing how much current is being dumped into the wheel motors.
So I've heard of like brushless motors and other kinds. Can you maybe walk us through what are the different kind of big categories of servos and motors, and kind of why each one is different from others?
Yeah, so with brushless motors, in the title, it has no brushes. So what is a brush? So I've actually got a sample of a hobby motor right in front of me. This is just an 18-volt, what they call like a CAN motor, and these are a really popular choice. You can pick them up from most electronics retailers, and so I can actually power this up pretty easily because with the brushless motors, you just give it power and ground, or really you go positive and negative, and there you go. It's as simple as just sending power, and you can reverse the motion by reversing the direction of the current or just switching your leads. Okay. And so these motors have pretty good torque and decent speed, but so this is a brushed DC motor. I'm going to actually pop it open. As you can see, those little black pieces right there. Yeah. Let's see if the camera can focus. Okay. So those black pieces, those are the actual brushes, and when they connect with the circuit inside the brushed motor, that completes the circuit and allows the current to flow. Now, the problem I just want to make sure the brushed motors
is it's actually making physical contact. That's the key, right?
Right, and so because it's making physical contact, the higher your speed and the more current you're putting through, there are obviously losses due to friction, and there's just some, losses in the design itself that make it somewhat less advantageous for like high-speed applications. The benefit of the brushless DC motors is that they've been around for a really long time, and there's been so much development on them that they have really great starting torque, And as long as you can keep the brushes alive, they're pretty reliable. But there are some cases, like in combat robots, there's been a paradigm shift away from the brushed motors, because during the heavy impacts, sometimes the brushes can break or come loose. And the last thing you want is for your robot to stop working because of something as simple as like just a brush coming free from the robot.
Yeah, can you show us some of the gadgets you have built? I think you're based on your background, you have built like a lot of cool things.
Yeah, I think the audience would love to see your collection of robots.
So this is my 1 pound combat robot lithium flower. So we've got a combination of brushed for the drive, that's these guys are right here, and then there's a brushless hobby motor right there for the weapon system. Normally there's actually a belt that connects this pulley right here to the motor.
Yeah.
Yeah.
So the weapon is this thing rotating, this arm rotates.
Yep, just like electric boogaloo, this is a kinetic energy-based vertical spinner. So there's normally 2 teeth right there. That one actually broke off in its last fight. So there's a good one. This is a grade 5 titanium bar that I milled out on my mini mill in my shop. And then the uprights are a 7475 alloy aluminum. And the base plate is also grade 5 titanium. Kind of hard to tell because of the awesome paint job.
Nice.
How long does it take you to come up with names? I imagine as long as building the robot, because lithium flower seems pretty distinct.
Lithium, part of the finesse of being a combat robot builder is awesome names. So you have like last rites, and every robot has their own theme. There's Team Plum Crazy, husband and wife team. Matt is a plumber, so all of his robots: Sewer Snake, Devil's Plunger, and then for Team Hardcore Robotics, I hope I said his name right. There's Last Rites, Tombstone, so a lot of them are sort of like Grim Reaper theme. My robots are a little more eclectic. I try to do the best job of confusing both my teammates and the other competitors each time I come up with a name. So Lithium Flower was a inside joke and reference to Ghost in the Shell.
Okay, cool. So how do you? So
it's a popular Japanese anime.
So there's brushless, there's brushed, there's continuous. So how do you control these different kinds of servos? What's the control mechanism typically, or what are the various types of control?
So for the brushed motors, it's in this case. So the brush motors take in just power and ground. That's the simplest way to control them. Now, if you want varied speed, or if you want, like in this case, it's actually a hobby RC receiver that sends a signal to VEX 29 motor controllers. And so that takes in a 3-wire servo signal and then does some computation and sends out power over 2 wires to the brushed motors. So as far as other control systems, we've also got, so these are 2-wire motors, brushed motors. A lot of the hobby brushless motors you'll see have 3 wires. Mm-hmm. So it's not simply just a matter of sending power and ground, which I'll actually demonstrate. And this is because of the architecture of brushless motors, which I'll get into. So if I power 2 of the wires, the motor actually just twitches.
Okay.
And so what's actually going on is, unlike the brushless motor where you just have to change the direction of the current inside, the brush motor, inside the brushless motor, you actually have all of these poles that you have to engage at different times in the rotation so that the field of the poles resists the magnetic field of the permanent magnets that are installed around the edges of the can.
So that
requires a...
So what you're saying there is, instead of on the brushless, what it is it's a series of electrically activated magnets that turn on and off in a particular sequence to get then the other magnets to travel basically in a circle and via signal. Is that correct?
That's absolutely correct. That's very similar to how they do like the linear accelerator for the old Superman drive, or Superman, the ride at Magic Mountain.
Okay.
Oh.
Actually, speaking of there's an Avatar, I think, world now with an animatronic, the most advanced animatronic ever built for the Avatar world.
Nice.
I don't know if you saw it, Brandon, but it's really impressive. It looks lifelike.
Cool.
Are there any questions from audience so far?
No, not at the moment. I was asking the audience if they had any awesome, kick-ass combat robot names, or if they had questions about parts.
Great.
Yeah.
So, okay, so can you tell us a little bit about kind of Robotis's, take on this? What problem is Robotis solving, and what are the various pieces and parts that Robotis is bringing to the table?
Yeah, so Robotis is a company that specializes in intelligent actuators. And so lately our focus is on jointed systems for humanoids. So like I've got a sample of our Robotis Mini over here. And so each of these joints on the robot is actually made out of actuators that control a different degree of freedom. So this guy has 16 or 17 different servos on him.
Wow.
And so moving forward, there are a lot of challenges in making humanoid robots, especially making ones that do smooth human-like motion or lifelike motion. And so that requires having a lot of sensory feedback from the servo itself. That's basically your primary sensor is the load on the servo, the temperature that it's experiencing due to the load. And that gives you parameters that you can then program around to create the smooth, fluid, lifelike motion for your creations.
Right. So yeah, so I think a little bit of context. So I got involved with Robotis, servos. After late 2015, I was involved in an AWS IoT project using basic hobby servos, and had some issues that I could send a signal to the servo, but I couldn't get anything back, like how much torque is being applied, what's the operating temperature, and I had burned out some servos, and so that's when I started searching on different other options and came across Robotis. And the way I kind of think about it is Robotis are smart servos, that each servo itself is a small embedded computer. And so not only can you send signals to the servo to say, do this or do that, but also get information back, like what torque are you experiencing, what position are you in, etc. So Brandon, can you maybe show us what are the pieces and parts that go into connecting some of these Dynamixel servos that we've been talking about?
Yeah, so the XL320 actually does a great job of that because it's got a transparent case. So right there, you'll see that's the control board that's giving, it's interpreting all the commands sent to it from the SBC, single board computer, or from your PC if you connect it to it. And so then what that does is, you send it a signal, maybe it's something like telling it to go to a 90-degree position. Mm-hmm. So then it has to figure out, okay, where am I in relation to that 90 degrees, and how do I get there? So once it figures out what it needs to do, like in this case, if it was at 0, oh, okay, well then I need to rotate through 90 degrees in the clockwise direction so that I can get there. So the first thing is it's going to send a power command to that little motor right there, which is really similar to the guy that I have separate from one of my robots over here. So the motor is going to transmit its motion through the gear train. Mm-hmm. So you can get it to focus on it.
Yep.
And so you have that motor that's creating the motion, and then you need to know how far you've traveled and have you arrived yet. So what you can't see is there's actually there's a magnetic Hall effect sensor that's doing the encoding. And so what encoding does is it measures how far something is moving, And then by taking incremental measurements of how far you've moved per unit of time, you basically have your velocity. And so the PID controller, PID stands for proportional integral derivative, the PID controller will do a fancy calculation of how far do I need to go, how quickly do I need to do it, and how can I do it without breaking anything. And then it'll arrive exactly on the position, and once it detects it's at its position, it'll stop.
Wow, that's great. Yeah, so
Awesome.
I'll show people how this actually works in code. Before we part with Brandon, I think, Brandon, do you want to show what are the controls available on a Robotis motor, like I think R Plus Manager?
You talking about the software?
Yeah.
So let's.
You want to show the software?
Yeah,
That'd be great.
once you switch to the R Plus, let us know, and we'll show your screen.
Mm-hmm.
Sure thing. Okay, so I've got our R Plus Manager 2.0 open.
Have you
And
shared your
this switch
screen?
screens now.
Hey,
have you shared
Brandon.
your screen, Brandon?
Yeah, there you go.
There you go.
Oops,
Yeah.
sorry, there we go. There was a little bit of a delay. Okay,
Sure.
can you see everything?
Yep. Let's do this quickly.
Okay, so this is
Yeah.
okay, so this is R Plus Manager. Basically, I'm already connected. I'm using our USB to Dynamixel to send commands to the servo. Well, it's a two-way communication device, so it's sending and receiving values from the servo. And then I'm just powering it with our SMPS to Dynamixel. So it's as simple as just finding the COM port that we've initialized, and then selecting the baud rate that we're communicating across, which is just the communication speed.
Seems like you guys built this to make it as easy as possible.
Yeah. So this.
Yeah,
so-
absolutely. Unfortunately, it looks like I'm having a Windows error, so the program has crashed.
All right. So let's do an imagine, if you will. So basically, what we're trying to show here is that there's software that you can run on your Mac or your PC, different versions that would allow you to basically receive information from the servo and send information. So Brandon, super awesome. Thank you. Why don't you kind of hang out with us while Anupam, then we're going to get into how to actually do the signaling from a Raspberry Pi to a robot arm. So
Sure, yeah. Let's jump into some of the putting whatever Brandon talked about into practice. Like how do we control the motors which Robotis has from a Raspberry Pi? And the input which we are getting is signals from AWS IoT. So AWS IoT is telling us, hey, somebody moved the hand by this much, or do something about it. And do something is something which we are doing here, like how do we control? So the first thing we are using here, let me show you some of the background. So one, we are using a Python SDK for AWS IoT. The reason we are using this is because we are running Python on our Raspberry Pi. If we were running some other language, we could use another SDK. There are a lot of SDKs available for AWS IoT. This is specific one. If you scroll down on the GitHub repository, it tells you how to use it. It's very simple. You just do a pip install, and then once you do a pip install, you just need to start setting it up. You just create a MQTT client. MQTT client is a client which can talk MQTT language or protocol. And once we have that, you can just say connect, publish, subscribe. These are the things which we use. Like so, connect means you connect to the endpoint. Publish means you're sending data to the endpoint. Subscribe means you're getting the data back, and all that. The second piece we are using here is Dynamixel SDK. So this is another link which will be useful. This SDK allows us to talk to Robotis motors in a programmatic way. We can say, hey, motor number 1, you need to move by this much degree or these many movements. So we can control how much each motor needs to move when an input is received. So this allows us to talk to the robot. There are a lot of things which are detailed here. For those who are watching, let me show you how to.
So while you're going to that, so I just want to kind of. So what we have here is. So we've got a Raspberry. We've got a Raspberry. Whoop! I got the Alexas in the way. We've got Raspberry Pi with a USB Dynamixel communication bus device, and then on the Raspberry Pi on a Palm, you've installed the Robotis CSDK.
Yep.
And then compiled it on the Raspberry Pi.
Yeah.
Right. And then the CSDK from Robotis has the ability to do external language bindings, basically.
Yeah,
right?
so essentially the language which Robotis is responding to is C, but we have bindings in Python which allow you to call those functions. So we are calling C from Python, so your program can still be in Python and make those calls.
Right, and so the benefit here is that when doing robotics, being a mere mortal, I can program in Python rather than getting down into C. And so what it means is that doing complex robotic applications is accessible to many, many more people. So we have this smart servo that with bidirectional communication that has a lot of built-in functions, but we can access it from Python, Node, Java, what have you.
Which is right there that Anupam is showing on the screen.
So this resource is available to all of you. All you need to do is go to bit.ly/AWS Maker Studio. This is how it looks. AWS in a camel case. When I hit this, there's a gist which we have created which goes through some of the links for all the episode which we have. So now we'll switch to episode 5, which is controlling the robot. And there's a SDK which I just pointed to. But this is the fun part. Like, how does this code work? So initially, we were thinking we'll code everything in front of you, but this is about 150 lines of code. So, and in the interest of time, we'll tell you how this works, and maybe in some time in future we can show you each piece. But this is something we have just taken from the SDK. So let me show you some of the interesting pieces from this code. So the first piece is we get import a AWS IoT SDK, and we are calling it AWS IoT MQTT client. Once we have this client, I'm calling it MQTT client, we are setting up a lot of things on this. We are saying what is the endpoint which it needs to talk to. We are saying what certificates it can access. This allows this client to have an identity of its own. It can say, hey, I am person X or I am client X, and let me talk to this endpoint. So these are some security related stuff. We covered this topic in episode 2. And then we are setting some of the same configuration for things which should be set. It's not necessary, but these are nice to have. All of this is available in our SDK documentation. Now this is the place where some of the things about Robotis are set here. So for example, how much torque what should be the torque value? What should be the velocity at which the motors move? What is the acceleration? So you can think how much control we have on these each of these parameters. I think a lot of these are things which you will learn by experiments. Some of these things are provided in a lot of documentation, but these are numbers we came up with to make the motion of the robot very smooth. And then we have a name for each motor. So our robot has 5 motors, so we have given them 5 different names.
Those are very inventive.
Yep. And then once we once we have that, we just the first function we have is open connection to the arm. So it's just opening a port to the dynamic cell motors. Once if the port connection opens, it also sets a baud rate. Baud rate as dependent torque. It allows you to have a speed at which the communication should happen. And then there are a lot of things which you are setting around how much torque should be set for each machine. So those were the variables defined on the top. We are just sending those variables to the motors in this piece of the code. Once we have that, then the most interesting piece in this code is this one. So let me start with this. So actually, I'll start with the end. So we start with MQTT client.connect, which means we connect to the client. Once we have connected, we subscribe to a topic, and whenever that topic message is received, we call an on message. So let's walk through this. So this is the entry point of our program. Whenever a message received, we go to on message.
Effectively the main.
Yep, so on message, let's see what is on message doing. Whenever on message is called, we say receive data and a payload. We just show the payload, and we convert it to a JSON and call a function called move arm. What happens in move arm? We are telling each motor how much they should be moving. So we are sending x-axis, we are reading the x-axis value from the data we received and sending it to the DXL. Similarly, we are reading z-axis, y-axis, and sending it to the respective motors. Once we have sent them, we call something called move arm to a position. So this is a specific position we want the move arm to move to. And the final function we call is write to DXL. So write to DXL means write to dynamic cell.
So it's almost like if you're dealing with files, it would almost be like write to file.
Yeah, so essentially we have done some maths to find out, hey, this was the input we received. how do we tell motors to move? So this is the final step where we tell motors. To each motor, we tell in a for loop. So this is the for loop where we say all DXL list, which means we go to all the dynamic cells we have, and we set their current value to something which was just in the.
So Anupam, Todd,
Yeah.
Voxel GG asks, so this can be controlled over the internet because it connects to AWS?
Yeah, so this is a very interesting question, yeah, because this can be done locally as well. Like you can have this run locally, but the interesting piece is your subscribers could be anywhere in the world, and you're getting data from them via AWS IoT, and then those motors are acting on that data anywhere in the world. So there was episode 3 where I was in Canada, and I was controlling this motor or this robot from Canada seamlessly.
But the thing is, it wasn't from Canada. So he was controlling the robot from Canada, but it was going to US East, and then from US East it was coming back here.
Yep.
Yeah.
So it was going to 3 geolocations while you were doing it.
Without an international incident.
Yeah, that was a very fun experiment we did. The good piece is because this data is in AWS cloud, you can do a lot of other things. You can like send an alert if specific action happens. You can do a lot of other things around it.
Yeah.
So the final piece is we write the data which we receive to each of the motors, and finally we say, hey, write is done, and just close the connection for those motors. We just say sync write is done. So this is a very specific call. If you are interested in building this piece, I would strongly encourage you to go to this link, which is bit.ly/AWS Maker Studio, and just use this code, and it will allow you to repeat whatever we are doing. And if you have more questions, you can just send an email to us, aws-twitch@amazon.com. You can also talk to us on our Twitter. So our Twitter handles are listed below. Definitely do reply.
I can't do it.
Okay, right here. Yeah, right here. If you can reply to us, we will be very prompt in responding to the questions you have.
No promises.
Great.
So,
awesome. So
Todd, what's happening next?
Yeah, so we just completed 5 episodes where we went literally from one end of the communication channel all the way to the other end of the communication channel with the cloud in the middle, talking about software and hardware and communication, the different kinds of pieces, and we basically showed how to use a local sensor to control a remote robot. And so what we're going to do in upcoming episodes is we're going to add machine learning and AI to our robot. So
we are thinking rather than humans controlling the robots, it'll be cool if they can do things by their own. Like
and send us some feedback on what we should do with machine learning and AI. That'd be really cool to hear.
So we have a little demo that we want to show here of our robot doing something pretty spectacular.
Yeah.
So what we're going to do is we're going to have the robot arm go to the Phil's truck down the street and get us a coffee and bring it back.
All of us a coffee, or
just one?
Just one.
Okay, awesome. Well, that was fantastic.
I can't believe it went all the way over there.
Oh my gosh!
It
went down the elevator and out in the street and came back and brought us a coffee. It's almost spilling a little bit, but
okay, let's bring it up.
Yeah.
So the robot got us a coffee.
Yeah.
Now, if you want to see how this happened behind the scenes.
Yeah, so in a few weeks, so stay tuned on all the regular kind of the AWS Twitch channel and on social media. In the coming weeks, we're going to add machine learning and AI to our robot arm, and we're going to walk through basically how to do that and how to do some exciting projects like this.
Yeah, we want robots to listen to us. We want robots to respond to us in audio, and also do a lot of intelligent things.
Yeah. And next time we'll have the robot have a GoPro on top so we can actually see it happen.
Oh, that would be great.
Really
yeah.
Cool.
Awesome. So I want to do a shout out to Brandon from Robotis for joining us today and walking through some of his experience with robotics and robots and Robotis. So anyway, so Anupam, you want to close us out for season 1?
So this was our season 1. We discussed how to build basic robots. For those who are watching this for the first time, go to YouTube and search for AWS Maker Studio, and you can catch up on all our previous episodes. And
on Twitch.
On Twitch too.
It's on Twitch too. So if you go to video section of Twitch, we have videos there as well. We believe that once people watch these 5 episodes, they will know about how basic robots work, what are the different pieces which go into it. The next season will focus on making them more intelligent, making them more responsive, and a lot of other things. You will see a lot of other episodes coming in future, but our show, AWS Maker Studio, will be taking a break for next few weeks. We will have some bonus episodes, but we will start our next season in upcoming weeks.
So we do have a question right before we close.
Sure.
Dimacert asks, but the code I have to run in the Raspberry Pi, that's the only thing I don't understand. So it sounds like, would they have to run the code to run it at Raspberry Pi?
So there you do need some local compute that's controlling the servos themselves. That could be anything simple from an embedded controller to an Arduino to a Raspberry Pi to an Edison to a BeagleBone, and you're going to run some code on that single board computer that's going to control your servos. There's lots of different kind of various ways to do that. The example that we chose was a Raspberry Pi and Python, but there's many different flavors of accomplishing this. And so we would love to hear, from the community, what boards are interesting to our community, what languages are interesting, and then we'll focus on those, but we just happen to choose Raspberry Pi and Python. So hopefully that answers the question.
Yeah, and if you build something, definitely let us know what you build. We would love to know what people are doing. Send us some photos.
Yeah. So there might be rewards and awards for things that folks send in that we showcase on the show.
Yeah, you can reply to us on Twitter or send us email. Either way.
If not, at very least give us robot names that we can use in the show. I guess for what we're developing.
Awesome.
Yeah, and this is we'll take a break for next few weeks. So thanks a lot for all the interest you showed in AWS Maker Studio. We'll come back in next few weeks, and we are very excited about what's going to happen in the next season.
Yep, awesome. Thanks everyone.
Thanks, guys.
Thank you.